Welcome back, everybody. It's me, Mr. Hare. I've got your new lesson 10-4 ready to go over. Hopefully you're paying attention in the video, and maybe you might even take some notes, and maybe you might learn something. We're going to continue with the idea of roots with parabolas. Where does it cross the x-axis at? And in this section of 10-4, we're going to have to factor to solve quadratic equations. So again, this whole idea is figuring out where does the parabola cross the x-axis, at what points, and hopefully we can figure this out without having to graph. So it might save you a little bit of time. So as you're paying attention and as you're taking your notes, keep that in mind, that you're looking for those two roots where the parabola is going to cross the x-axis. So if you would take a moment to write down our first problem, x plus 3 times x plus 2 equals 0. You'll notice that you've got two binomials and they're both set equal to 0 in this problem. Well, what we are going to use today is called the zero product property. And you know what that is, you may just not know what it's called. The zero product property is when you have any two things multiplied together. If one of them is 0, well, guess what? The whole thing is going to be 0. If A times B is equal to 0, then either A or B, if either one of those are equal to 0, then the whole statement is going to be equal to 0. Well, that's going to stay true for our binomials. If either one of these is equal to 0 when we multiply them together, that's going to give us an answer of 0. And in that, we'll eventually find out what our roots are. So if you look at the first binomial, x plus 3, well, what would x have to be to make this whole set of parentheses here equal to 0? Well, you can set up an equation. X plus 3 equals 0. Subtract 3 from both sides. Well, if x is equal to negative 3, that whole parenthesis set, that'll be 0. Well, what about on the other side? You can probably look at it and guess, but just to be thorough, we'll set it up as an equation. X plus 2 equals 0. Subtract 2 from both sides, and you get x is equal to negative 2. So what you've just done is you've told me where a parabola is going to cross the x-axis. It would cross at negative 3 and at negative 2. Please be sure that this is always set equal to 0 before you start your problem. All right, let's look at another one. Here you have two binomials, x plus 7, x minus 4 is equal to 0. Take a second and see if you can figure out what the answers, what the roots are going to be for this set. You can set up two equations, set them both equal to 0, solve for x, and you get your answers of negative 7 and positive 4. Again, that's where the parabola is going to cross the x-axis. All right, well, those are pretty simple because the binomials are already given to you. Well, let's make it more difficult. X squared plus 6x plus 8 equals 0. Remember, always has to start off equal to 0. In this case, it does. I wonder if later in the video we're going to come up with some that don't equal 0. All right. So, factor. You know how to factor a trinomial now. So x squared plus 6x plus 8. Factor that into x plus 4 and x plus 2. Now you could set those two binomials equal to 0 and tell me what the roots are going to be. A little back and forth there, and then you've got negative 4 and negative 2. All right. See if you can do this one on your own. X squared minus 8x minus 48 equals 0. So pause the video. Take a second to figure out if you know what the two roots would be. All right, the magic of video, I know what the binomials will be immediately. X minus 12 and x plus 4. I can set up my two equations, add 12 to both sides, and I get x equals 12 for one of the roots, and then subtract 4 from both sides, and I get x equals negative 4 for the other root. So then if I want to list those, I've got x equals, negative 4 and 12. So my two roots are when it crosses negative 4 and 12 on the x-axis. All right. Very good. Now, what do we do? What do we do? I don't know. 2x squared minus 5x equals 88. And this big red arrow is telling me that it has to be 0. But it says 88 on that side of the equation. Just a second. Ah! I've got it. What if we move the 88 to the other side? There it is. Subtract 88 from both sides. Left with 0 on there. Look at that. Red arrow comes back. Red arrow is happy. Now I've got 2x squared minus 5x minus 88. I've got a coefficient before the x squared. You might want to use the magic squares on this one. Or you can just wait until I press the button, and it'll show you that it factors into 2x plus 11 times x minus 8 equals 0. You can set up your two equations now equal to 0. Subtract 11 from both sides. Divide both sides by 2. You get x equals negative 5.5. This one's a little easier. Add 8 to both sides, and then you get x equals 8. So your two answers are going to be negative 5.5 and 8. Here's another one. What do you think you have to do first on this one? Here comes red arrow. There it is. Did you say add 36 to both sides? That is correct, because then after you do that, hey, it is set up equal to 0, and now you can factor x squared minus 12x plus 36. Those two binomials, x minus 6 equals 0. Set up those two equations. Add 6 to both sides, x equals 6. Add 6 to both sides, x equals 6. So your answer is just going to be 6. You don't have to list it twice. I wonder what that would mean. What would that look like on a graph if there's only one answer? Take that answer back to your teacher tomorrow, either Miss Gokin or myself, and tell them what you think. If there's only one answer when you solve the quadratic equations this way, what does that mean on the graph? All right? So, with those few examples that we went over, a real quick review of what you're going to be doing in 10.4 is, 1, you want to make sure that the equation is set equal to 0. Don't make me get the red arrow out. Then after you've made sure it's set equal to 0, you want to set each binomial equal to 0 after you factor. Doing that, then you get to solve for the variable in each binomial. Or if you would like, you could sauver. That's French for solve. I hope that this video helps you with 10-4, and I also hope to see you in class. Bring any questions that you have to Ms. Gokin or myself, and good luck with